Salutations, YouTube. Today I'm making a video for my pre-calculus class over logarithmic properties, and I'm going to discuss the power rule, the product rule, quotient rule, and the change of base property, and then do some examples. Not all in that order, but you get the gist. And as you may or may not have heard from that other weirdos video, this isn't the type of video that we're going to do on this channel, but since this is a school assignment, I'm sure all of my classmates are gonna watch this video. We figured we'd host it on this channel and maybe get some more views of our work. So these rules require the variables such as the base and the numbers in the parentheses to be both positive and real, and for any exponents that may be in there, they should be real, but it doesn't matter whether they're positive or negative. So for the product rule, the logarithm of the product of the two variables is equal to the sum of the two individual logarithms with the same base of the two numbers. So for the product rule, let's say we start with logarithm of base 5 of 7 times 5. Now we could try to simplify 7 times 5 to 35, but that's not going to help us to evaluate the expression without a calculator. So what we can do is change it to log base 5 of 7 plus log base 5 of 5. And we can't do anything with the left side, but log base 5 of 5 will simplify to 1 because 5 to the first power is still 5. The quotient rule says that the logarithm of the quotient of two variables, or log base b of x over y, is equal to logarithms of the two variables, of the difference of the logarithms of those two separate variables, or log base b of x minus log base b of y. For the quotient rule, start out with log base 3 of 405 minus log base 3 of 5. Now that doesn't really mean anything to us, but we could condense it to log base 3 of 405 divided by 5, or over that. And that's obviously, 405 is obviously divisible by 5, and if you punch it into the calculator, you get log base 3 of 81. And if you know your multiplication, you'll know that 3 times 3 times 3 times 3 is 81, so it is 4, because 3 to the 4th is 81. So the power rule states that the logarithm of a number to an exponent, or log base b of x to the p power, is equal to the product of the exponent and the logarithm of the number, or p times log base b of x. So essentially you just take the p and put it in front. So for this rule we have natural log of e to the 4th. And this can also be written as log base e of e to the 4th, just so you see the similarity. And we can take the 4 and put it in front, and since e to the first power is still e, natural log of e simplifies to 1, and 4 times 1 is 4. So the change of base property says that the logarithm of a number, or log base b of x, is equal, or can be represented as, the logarithm of the original number with any new base, or log base n of x over the logarithm of the old base with the new base, or log base n of b. Now that probably sounds confusing, but it'll make more sense once we do some examples. So for the change of base property, I picked log base 100 of 10,000 because they're really nice numbers and it's easy to see what's going on. Now, if you know your multiplication, you can see this is just 2, because 100 times 100, or 100 squared, is 10,000. But you can also prove it by saying common log of 100, or 100, common log of 10,000 over common log of 100 is equal to, the top is 4 because 10 to the 4th is 10,000, and then the bottom 10 to the 2nd is 100, and then 4 over 2 would simplify to 2 as well. Thanks for watching this, and be sure to check out our other work.
Or Ben will